Good morning to all. Welcome to the Diamond Group of Institutions online classes NEET and K-CET. Today's topic it is molecular basis of inheritance. So in that molecular basis of inheritance, some of the questions are we have discussed. In that first one it is, which of the following is absent in most stable genetic material? So you want to know here most stable, which is the most stable genetic material. So in the nature, two genetic materials are available. One it is DNA and other one is RNA. Out of these two, question asking as a most stable genetic material. That most stable genetic material is DNA. RNA also genetic material, but compare into the DNA, RNA it's not more stable than the DNA. So the question regarding to the DNA only. So in these of the DNA, which of the option is absent? So in the options are they given as some of the structures. That structures are option A, it is 6-aminopurine. That 6-aminopurine, it's also called as a adenine. And option B, they given as a sugar and the nitrogen base. This is sugar and nitrogen base only they mention. So nitrogen base is attached into the first portion of the sugar or first position of the sugar. We can call as it is a nucleoside. And option C they given as a 5-methyl uracil. It is also called as a thymine. And option D they given as a nucleotide. That is, that nucleotide it is adenine, nitrogen base and sugar and phosphate molecules. Here by the seeing of the structure of the sugar molecule, second carbon atom of the sugar, in that hydroxyl group it was mentioned. Actually in the DNA, instead of the hydroxyl group, hydrogen group will be going to present. If the hydrogen group it was present, that sugar molecules are seen in a DNA. Instead of the hydrogen group, hydroxyl group it was present. These hydroxyl groups are seen in a second carbon atom of the deoxyribose, otherwise ribose sugar or pentose sugar. If that second carbon atom hydroxyl group it was present, means that is we call as a, that is a character of RNA. So all of the three options are adenine, nucleoside and the thymine we are seen into the DNA molecule. But coming to the nucleotide, that is we are told as here, according to the options are they given deoxyadenosine here. But in these are the deoxyadenosine, structurally instead of the hydrogen group, hydroxyl group it was mentioned. So that's why option D, it's a absence in DNA. In the most genetic material it is a DNA only. In that most genetic material of the DNA, sugar molecule, second carbon atom, instead of the hydroxyl group, hydrogen group should be present, but in the option they given as a hydroxyl group only. So that's why answer it is D. And next one it is, which one of the following mRNA will not translate completely? You know, here in the molecular basis of inheritance we seen as replication, transcription and translation. Replication means synthesis of the DNA from the parental DNA. Transcription, synthesis of mRNA from the DNA. mRNA synthesizing takes place, that is called as transcription. And translation means synthesis of protein from mRNA. This is called as translation mechanism. So question it is, which one of the following mRNA will not translate completely? Means these all options are given as a mRNA. Out of the options, which mRNA will not translate? Means which mRNA does not synthesize completely to the protein. Options are given as option A, AUG, AAA, CCA and UUU. These are the codons present on mRNA. So by the imagine of genetic code, genetic code contain as a 64 codons. Out of the 64 codons, 61 codons are there involved into the protein synthesis, or 61 codons are that encoded by the 20 amino acids. Remaining 3 codons are withdrawn as stopping codons or nonsense codons. So now here in the option A does not having any stopping codons. These are the 4 codons are that encode into the 4 amino acids. But when we see into the option B, AUG, UAC and UAA and UCC. So these are the option B. One of the codon will be don't presents, that is UAA. Stopping codons are 3, UAA, UAG and UGA. So out of these three are withdrawn as a stopping codons. Function of these 3, wherever the stopping codons are there present, they can stop the synthesis of transcription and they can stop the synthesis of translation also. So this is in the B option, UAA, it was interrupted into the mRNA before the UCC. So that's why that at the time of translation mechanism, AUG will be don't code by the one amino acid and UAC will don't code by the other one of the amino acid. But UAA does not code by any amino acid. So here this UAA it's called as a stopping codon. So whenever the translation mechanism it's reached into the UAA, they can stop the synthesis of translation. And option C, again AUG, CCC, CCA, UUU. These are the 4 codons are that encoded by the 4 amino acids. So option A, option B and option C. In the option A and option C does not having any stopping codons. But option B only one stopping codon is there, that is we call as UAA. Whenever the UAA is there, it can stop the synthesis of the translation mechanism. So that's the reason option B, mRNA does not translate completely. So answer it is B only. Third one, select the correct options for the given blanks in RNA. There are dash types of nitrogen bases. They can form dash possible combinations of triplets called codons. Among these, dash codons serve as a termination codons and remaining dash codons are sense codons. Question made based upon the NCERT lines only. See now, in RNA there are dash types of nitrogen bases. So RNA, it's contained as a nitrogen bases are adenine, guanine, cytosine and uracil. So adenine, guanine we call as a purines, cytosine and uracil we call as a pyrimidines. So in RNA there are total number of nitrogen bases are 1, 2, 3, 4, means adenine, guanine, cytosine and uracil. So there are 4 types of the nitrogen bases. They can form dash possible combination of triplet codons. So you know about that. These are the 4 nitrogen bases are that can form into the 64 codons. They can form into the 64 possible triplet will be going to form. You know that is we are seen into the genetic code. So by the using of these 4 codons, by the using of these 4 nitrogen base only, will be get into the 64 triplets codons. Can form 64 possible combinations of triplets called as a codons. Among these, out of these 64, among these dash codons are as a terminating codons, means out of the 64 codons, 3 codons are withdrawn as a terminating codons. Terminating codons are we are also called as a stopping codons. So those are the 3 are UAA, UAG and UGA. These 3 we call as a stopping codons. So remaining as a 61 codons, that 61 codons are withdrawn as a sense codons. So these are the 61 codons are that encode into the 20 amino acids. So now based upon that sentence, see now in RNA there are 4 types of nitrogen bases that can form 64 possible combinations of triplets called as a codons. Among these, out of the 64, 3 codons serve as a termination codons, and remaining 61 codons are sense codons. So options are in the blanks 1, 2, 3, 4. So out of the 4 options, out of the 4 blanks, first blank RNA contain as a 4 types of the nitrogen bases. So 4 types of the nitrogen bases. Option B and D. And next, based upon the second one, they can form into 64 possible triplet codons. So here the option D they given as 64 possible triplet codon, and option B they given as a 256 codons are not from 64 only. So answer it is a D. Next question. In one polynucleotide strand of DNA molecule, the ratio of adenine plus thymine by guanine plus cytosine is 0.3. What is the ratio of adenine plus guanine by thymine plus cytosine ratio entire DNA molecule? The question they given as a polynucleotide chain. These are the polynucleotide chain. Adenine, thymine and guanine cytosine ratio is 0.3. We have to estimate adenine, guanine and thymine cytosine ratio. So here nothing to explain, it's simple and direct only. So we know the Chargaff rule. He proposed as, and he said as, number of purines equals to number of pyrimidines. So here number of purines are equals into the number of pyrimidines. If you are taken as a number of purines, those are equal to the number of pyrimidines. If you are taken as a purines by pyrimidines, those are equals to 1. So this one it's constant. So according to this Chargaff rule, A plus G, adenine and guanine, those are the purines, thymine and cytosine, these are the pyrimidines. So purines by pyrimidines, and number of purines are equals into the number of pyrimidines. Adenine, guanine, those are the purines, and thymine and cytosine, these are the pyrimidines. Purines by pyrimidines, they will be going to get the value, it is 1, it's a constant. So that's the reason answer is a D. And next question 5. If the length of E. coli DNA is 1.36 millimeters, then how many base pairs are present in E. coli? This is also the direct question. So 1.36 millimeters of the DNA, it is equals into how many base pairs? So let us calculate. This is 1.36 into 10 to the power of minus 3 by 0.34 into 10 to the power of minus 9. So we'll be get into 4 into 10 to the power of 6. So now answer it is E. coli bacteria, it's contained as a 4.6 into 10 to the power of 6 base pairs. So directly also we can just get the answer, but you want to know the explanation. So for conversion or converting of the length of the DNA, if the length of the DNA they given as a millimeters or the meters, we can multiply into the 0.34 into 10 to the power of minus 9. So these are the millimeters or meters, or we have converted into the base pairs. So by the using of the 0.34, that 0.34 it says as distance between the two successive nitrogen bases, and 10 to the power of minus 9 we are going to use into converting of millimeters into meters. So answer will be going to get as a 4.6 into 10 to the power of 6 base pairs. So it's related as 4.6 into the 10 to the power of 6. So answer D. And next question number 6. Which which DNA molecule among the following will melt at lowest temperature? Which DNA molecule among the following will melt at lowest temperature? So they given as options here. So the DNA melting point, it will depend upon the nitrogen basis. So how these are the DNA melting will be don't depend upon the nitrogen basis. So you can see the structure of DNA. DNA is made up of by the nitrogen bases. Those nitrogen bases are purines and pyrimidines. Purines are adenine, guanine. Pyrimidines are cytosine, thymine. According to the Chargaff rule, always purines are pairs with the pyrimidines. So now adenine always pairs with thymine with 2 hydrogen bonds. These are the H2 bonds. And guanine always pairs with the cytosine with 3 hydrogen bonds. These are the 3 hydrogen bonds present in between the guanine and cytosine. So if the hydrogen bonds are less, melting point is less. If the hydrogen bonds are more in between the 2 nitrogen bases, melting point also more. So let's see. Here adenine and thymine can pair into the 2 hydrogen bonds only. Because of the presence of 2 hydrogen bonds, these are the adenine and thymine bond break will be easy. And guanine and cytosine, so they can pair with the 3 hydrogen bonds. You have to break the guanine and cytosine. In between these two, 3 hydrogen bonds are there. So for the breakdown of the 3 hydrogen bonds, much temperature is needed. So here the less temperature, less energy is required to the separation of adenine and thymine. More temperature and more energy is needed into the breakdown of guanine and cytosine bonds. So now you see the option A. It's contained as a adenine, thymine, guanine, and thymine, guanine, and cytosine. Here adenine 1, 2, thymine 3, 4. Adenine thymine number it's 4. And option B 1, 2, 3, 4, 5, 6. And this is a 7. And option C adenine and thymine numbers are 2, 3, 4 only. And option D 1, 2, 3, 4 and 5. Out of the 4 options, which of the option they contain as more number of adenine and thymine molecules, those option it's having less melting point to the temperature. So according to those, option A it's contained as 1, 2, 3, 4 adenine and thymine number, and option B 7 adenine and thymine molecules are there, and option C 4 adenine and thymine molecules are there, and option D 5 adenine and thymine molecules are there. So according to that, more number of adenine and thymine molecules are seen into a B option. So answer it's a B only. Let's see the 6th question. If molecule of DNA has 20 adenine and 30 cytosine, a DNA molecule have 20 adenine and 30 cytosine, what will be the total number of purine base in it? So you have to calculate the total number of nitrogen bases in a given DNA molecule. Further, so again we have to apply the Chargaff rule only. Number of purines are equals into the number of pyrimidines. So you know that adenine is a purine. So adenine, they are having 20. It's a purine. And other one of the hint it is they given cytosine 30 molecules, means pyrimidines. So adenine and guanine, cytosine and thymine, those are the cytosine and thymine, those are the pyrimidines, and adenine, guanine, these are the purines. So adenine they are having 20 number, means thymine also will be having 20 number, and cytosine they given as a 30 number, means number of cytosines are equals into the number of guanine also. So now question they are asking, if the molecule of DNA have 20 adenine, 30 cytosine, what will be the number of purines? They are asking number of purines. Number of purines are adenine and guanine only. So adenine having 20 and guanine having 30. So 20 plus 30 will be the 50 purines. So these are the 50 purines and 50 pyrimidines. Out of the 50 purines, 20 belongs into adenine, 30 belongs into cytosine. So based on the 50 nitrogen bases will be in 50 purines are present in the given DNA molecule. So answer is a 15 only. Next question, 7th one. There are 20% of adenine among the bases in the DNA fragment measuring 68 nanometers in length. The number of pentosugars, nitrogen base pairs, phosphate group and hydrogen bonds in this DNA fragment are respectively. So they given as a 6.8 nanometers length of DNA. We have to find out pentosugar, nitrogen base pairs and the number of phosphate groups and number of hydrogen bonds in the DNA fragment. So for this, they given as a hinted length of the DNA, it is 6.8 nanometers and 20% of adenine. So by seeing the structure of DNA it's a double helical polynucleotide chain. So it will be drawn to bend and it's contained as a curves. So we can see about the structure of the DNA. These are two DNA strands are connected together by the presence of hydrogen bonds. So when we can imagine about the structure of the DNA will be going to having many number of the helix. Helix means we call as a turns or we are also called as a circles. So 6.8 nanometers. Generally, one turn it is equals to 3.4 nanometers or 34 angstrom units. Means one turn or one helix of the DNA strand it is. Here they given as a 6.8 means 3.4 into 2 will be that as a 6.8 nanometers according to that. So this is the one turn and these are the two turns. Each one of the helix, that is 3.4 nanometers of the DNA, it is equals to 10 base pairs. So now 6.8 nanometers otherwise 3.4 into 2 will be that as a 2 turns. It's contained as a 40 base pairs of nitrogen bases. So now based on that, it's contained as a 6.8 nanometers length means 2 turns of the DNA. 2 turns of the DNA we are also called as a 2 helix. Each helix it's having 3.4 nanometers. So out of that each helix or each 3.4 nanometers otherwise 34 angstrom units it is equals to or they contain as a 10 base pairs. 10 base pairs means 20 nitrogen bases. So out of the 20 nitrogen bases, here the one helix equals to 10 base pair means with there equals to 20 N2 bases. So 2 helix are equals to 20 base pairs means 40 N2 bases. So out of the 40 N2 bases, out of these 40 N2 bases, adenine they given as a 20%. So we have to calculate how many number of adenine molecules are there present. So total number of nitrogen bases are 40 and these are the nitrogen bases are they are given as a nitrogen bases 20%. So now we'll put it into the number of adenine molecules means 20% of the adenine molecules are equals to 8 means 8 adenine molecules are there present. 8 adenine molecules means these are the 20% equals to 8 adenine. If that 8 adenine molecules are there present means they are equals to 8 thymine means out of the 40 here the 40 N2 bases totally. Out of the 48 are adenine, 8 are thymine. So 40 minus 16 will be that as 24. This 24 it belongs to guanine and cytosine. So guanine and cytosine, each one they contain as a 12 and 12. So now total number of the nitrogen bases are 40. It is equals to it is equals to 6.8 nanometers length of the DNA. So based on that, 40 nitrogen bases, number of the pentosugar. So each one of the nitrogen base, it is equals to 1 pentosugar, means one nitrogen base contain as a 1 pentosugar. So 40 nitrogen bases means number of pentosugars are 40. Here number of nitrogen base pairs they are asking. Bases are 40, base pairs means 20. And phosphate groups, so number of the pentosugar and number of the phosphate groups are equal only. So 40 number of phosphate groups and number of hydrogen bonds. Here only some little bit confused you will be doing it. Hydrogen bonds in between the adenine and thymine, guanine and cytosine will be doing different. So you can see adenine molecules are 8, thymine molecules are 8. 8 adenine molecules pairs with the 8 thymine molecules. In between these two hydrogen bonds are there present. Means in between the adenine and thymine 16 hydrogen bonds are there present, and 12 guanine molecules and 12 cytosine molecules. 12 guanine molecules and 12 cytosine molecules. In between that guanine and cytosine 3 hydrogen bonds are there present. 12 into 3 will be drawn to get as a 36. 36 hydrogen bonds are there present. There 16 plus 36 will be drawn to get into 52 hydrogen bonds are present. So now you can see the answer respectively. Number of the pentosugars are 40, number of nitrogen base pairs are 20, number of phosphate groups are 40, and number of hydrogen bonds present in between the adenine, thymine and guanosine, cytosine, it is a 52. So answer it is option A, they given as 52, 20, 20, 40 respectively. They given means in the sequence order first it is a 40, means 40 says as a pentosugar. So option B and D, first option they given as a 40, and next one it is nitrogen base pairs. In the option B they given as 52 instead of the 52. In the D option, after the pentosugar nitrogen base pairs are 20, so answer is a 20. 40, 20, 40, 52. 40, 20, 40 and 52. So that answer it is D. Next, which of the following option is releasing factors? So about that releasing factors are, we can see the releasing factors at the time of translation mechanism. They can stop the synthesis of protein. So by the using of some factors, those are the factors are we call as releasing factors. Option 1 they are given as a EF1 and EF2. So E represent as a elongation. So elongation factor 1 and elongation factor thermo unstable. These are two factors are we are seen in the translation mechanism of prokaryotes, that is in elongation mechanism. So elongation means they can enhance the synthesis of protein. But the question they are asking as a releasing factor means they have to stop the synthesis of protein. So option 1 means elongation factor 1, elongation factor thermo unstable. Those are not the releasing factor, those are the elongation factors. And I1, I2, I3. So these are the I1, I2, I3 will not seen into the translation mechanism. Instead of that, initiation factor 1 and initiation factor 2, factor 3, those are present. Those are represented as IF1, IF2, IF3. See now, option D, IF1, IF2 and IF3. So these are the IF1, IF2, IF3 we are seen in a prokaryotes. So I represent as initiation. Initiation factor 1, initiation factor 2, initiation factor 3. So these are the three types of the initiation factors are we are seen in prokaryotes. Initiation means they can start the synthesis of protein. And option C, RF1, RF2, RF3. So these are the three factors are we are seen in prokaryotes. They can call as R means releasing factors. Releasing factor 1, releasing factor 2, releasing factor 3. These are the three types of releasing factors are seen in a prokaryotes. They can stop the synthesis of protein. So releasing factors are out of the given options C only. And question number 19. Which of the following isotope was used by Messelson and Stahl during their experiment? Messelson and Stahl's experiment we are seeing into the transformation test for the DNA replication. He was used as a heavy molecular weight of isotopes. That heavy molecular weight of the isotopes are N15. So N15 isotope he was used into the experiment. So answer it is N15, and S35, O18 and P32. S35 and P32, these are the radioactive isotopes. S35 it is a radioactive isotope of sulfur, P32 is a radioactive isotope of phosphorus. Hershey and Chase experiment, these two of the options are will be going to use as a sulfur and phosphate, and remain as a oxygen 18 isotope. It is used into the photosynthesis mechanism. Oxygen is evolved from the water, not from the carbon dioxide. There we are going to use it. So answer it is in the Messelson and Stahl's experiment used by N15 option, N15 isotope. And 10th question, in mRNA the sequence of nucleotide is given. Find out the sequence of amino acids in the polypeptide translated. So now the question they are given as a mRNA sequence. That mRNA sequence, it is synthesize the polypeptide chain, that is into the protein synthesis will going to take place. So this is the mRNA sequence. This mRNA sequence will be going to synthesize into a polypeptide chain. That polypeptide chain, it is made up of by the different types of the amino acids. The sequence of codons are followed by the sequence of amino acids. See now here AUG, GUG, CCG, UUU and UAG. So these are codons. These codons are the encoded into the particular amino acids. So you want to know clearly about these are the which codons are that encoded by which amino acids. You want to know the genetic code. So by the knowing of the genetic code, based upon the reference of the genetic code, AUG it's called as the initiation codon. It's encoded into the amino acid of methionine. GUG it encoded into the amino acid of valine. And CCG encoded into the amino acid of proline. UUU encoded into the amino acid of phenylalanine, and UAG it's a stopping codon. So AUG it's a initiation codon. Yes. AUG it's a initiation codon. It's encoded into the methionine. GUG you can see as a GUG, GUA, GUC, GUU. These are the four codons are coded by the amino acid of valine. In the same way, CCG can code the amino acid of proline. So when we see into the proline, codons are CCU, CCA, CCC, CCG. These are the four codons coded by the amino acid of proline. And coming to the UUU amino acid, UUU encode the amino acid of phenylalanine, and UUA also encoded by the amino acid of phenylalanine. So based upon that, AUG is a methionine, GUG is a valine, CCG is a proline, UUU is a phenylalanine. This is the stopping codon. So options are methionine, leucine they are given, leucine it's not right, proline, and phenylalanine, tyrosine, methionine, phenylalanine they are given. But option C, methionine, valine, proline, phenylalanine. So and remain it's a stopping codon. So answer it's a C only. And option D 1C, methionine, and second codon they are given as a proline. It's not a proline, it's encoded into the valine only.